All right, welcome everybody. Let's go ahead and get things going today. First off, just wanted to go over some logistics. We got some important things coming up. Let's take a step back though. Last week, I know I was out sick. I hope that you all got what you needed. Never a good time to get sick, but yeah, just a rough week for me. I hope you're all doing well. I just want to make sure though, it's very important to me that I realized I was not at 100%. Still want to help make sure you learn this material, help make sure you understand this stuff. I know recursion is not the easiest topic that we teach in this class, so please, if you are having questions with recursion, struggle with recursion, come on in and see me. I'd be happy to chat with you in my office. I'll go over the whole lecture for you again in my office if that's what would help you, right? It's my job. I want to make sure that you learn this stuff. That's what's most important to me. So if me being sick last week made that tricky for you, come on in. Let me know what I can do to help you get back up to speed. The other thing I wanted to bring your attention to is the fact that next week we're going to be having our second exam. So there's a couple things we need to chat about regarding the exam. The material that we're talking about today, so Module 7, is actually not going to be on that exam. So 4, 5, and 6 is the material that's going to be covered on that exam. If it were up to me, we'd probably be having the exam this week, actually. But with the evening exams, with the big classes, the university has to juggle us around, so it just didn't quite work out. It's not ideal. I'm not super thrilled about it, but it is what it is. We'll get through it okay. I just want to make sure that everybody is 100% aware of the fact that what we're talking about today, Module 7 on objects, is not going to be on exam 2. It is very important. It will be on exam number 3 coming up at the end of the semester. And then the assignment 7, you can also see on Canvas, is not due until after the exam. So you've got a couple weeks before that assignment is due. We are going to do Studio 7 this week because we do still have class later on this week. But next week in class is all dedicated to the exam. So 1 week from today, I'll be having an exam review session in here. I'm going to post the practice quiz and the repository with coding problems either tomorrow or maybe Wednesday. So keep an eye out for that in the next day or two. And then next Wednesday and Thursday, there's no studio, but of course we'll be available in the lab so you can come and ask questions about the exam, or if you want to work on the assignment, you're welcome to do that as well. So just want to make sure you're aware of what's coming up in the next couple of weeks. Somebody have any questions about exam stuff, logistics stuff, before we hop into today's topic? Anything I can answer about the exam? Yeah?
There is an assignment next week?
There's no assignment due next week. No, if you take a look at the calendar, exam 2 is next week, but assignment 7 is not due until the following week. So you've got more time for that one. Assignment 7 is not on exam 2. So it will be on exam 3. Any other questions that I can answer about the schedule or anything else coming up before I hop into some code? Okay. Fantastic. Great. So today's a very, 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 very important topic. Actually, basically everything that we've been talking about this entire semester, starting all the way back at week 1, it's kind of been leading up until this moment. So today's topic is objects. It is, as I said, a very important topic, and I think it's important to understand why. There are different ways that people can, write programs and interact with the computer. However, this idea of object-oriented programming is one that really started to take off back in the late 80s, early 90s, and has stuck around with us ever since. It has become by far the predominant way that we think about computer programs, using object-oriented programming. So when I introduce you to objects today, that is a concept that is used far and wide across many different disciplines within the realm of computer science. So even if you're going off to do bio or medicine or mechanical engineering or business or whatever it is that you're interested in computer science for, objects are probably going to be part of that process at some point along the way. It's that important. It's that big of an idea. Java, the language that we're using, is pretty well known for its object-orientedness. That was kind of its big claim to fame, is that we're going to take this idea of object-oriented programming and just really lean into it super hard. So that's a great language to use to learn objects, but not the only one. So, another question I get asked about a lot in this class is what languages people use and what languages people should be using, what languages you should be learning. I know a lot of people learn Python. It's another common language. Python does objects too, but it's not the only one. Some people like to use C#, C++, also object-oriented languages. So even if Java is not the language that you expect to be doing your research in or your projects in or whatever it is the case, chances are you will still be using objects. And they might look a little bit different in whatever language you end up using, but the concepts that you're learning about related to objects today are going to hold true regardless of what language you use, what programs you're working on. So hugely, hugely important concept. Let's start digging in. Objects are defined by a class. So we've been using classes actually since the very first day. And the very first day, sat up here, showed you public class hello, I believe, that just printed out a very simple message and kind of said, well, we're going to ignore this for now and we'll come back to it later. And it's later. Today is later. A class is a template. It's a blueprint. It's a definition of an object. So a class by itself does not actually do anything. It's just a template. And a class is going to contain two major categories of things. So the first chunk of today, we're just going to spend time talking about what a class is, what it does, the different parts of a class, the anatomy of a class. And then we'll spend the rest of the time digging in to these things in a little bit more detail. First up here at the top, the first category of things that I expect to see in a class are called instance variables. There's actually a lot of different names for these. So instance variables, fields, properties, attributes are all terms that, while they might mean slightly different things in certain contexts, generally all refer to this concept of instance variables, what we see at the top of a class. So these are attributes, right? These are the attributes, the properties that our class contains. So a class is a thing. It's an object. In this case, you can see that I'm telling you I intend this class to represent a person. So what does it mean to be a person? At least for this program, right? To be a person, that means that I have a name, an email address, and a phone number. Those are the attributes that people will have for the context of this program. These are known as our instance variables. And you can already see that we're doing things kind of differently, right? This is the first time that we've asked you to put code outside of a method. This code is not within a method, right? It's in the class. You can see it's inside of the class, but it's just kind of floating in between the methods. We haven't asked you to do that before. We also see this word over here, private. All of these instance variables are marked private. You can probably guess that private is, sort of the opposite of public, which we have been using quite a bit. Today, a little bit later on, I'll show you the exact difference between those two things. But for now, I think it's important to note that all instance variables are going to be marked private. All of them, at least for me in this class. Otherwise, though, instance variables look like variables. And that's, in fact, what they are. They are class-level variables or instance-level variables. You might hear them referred to. They're variables, so they have a type and a name. And you can see that Eclipse is helping us identify the fact that they are instance variables by coloring the variable name in blue. We can see these instance variables throughout the entire class. So before, if I created a variable within the method, right, we talked about this. The scope limited it to being used within that method. But these instance variables can be used anywhere within the class, in any method. And that makes them particularly useful to us. We now have another way that our methods can communicate with each other by manipulating these instance variables. It's a very powerful technique. These will almost always be up at the start of the file, although I do want to point out that Eclipse doesn't really care where you put your instance variables, so I just grabbed them and chucked them, 2/3 of the way down. Don't do that, please. It's not a good idea. Can you do it? Yes. Will your code still work if you put them there? Yes. But a big part of programming isn't just does it work, but can you understand what's going on? Can other people understand what's going on? If I open up a file, I'm going to look at the top of it and expect to see the instance variables there. And if they're not, I'm going to be like, well, what's wrong with this person? Why are they being mean and putting their instance variables somewhere strange, right? You're now programmers as well. You need to be nice to your fellow programmers as well as yourself and put your instance variables up at the top of the file. Always, always, always keep them up there at the top of the file. It's a quick place to look if you ever need to check and see what the instance variables are for a class. So that's the first category of thing I expect to see in a class. A little bit later on, we'll talk about public versus private in more detail. But first, let's move on to the second category of thing that I expect to see in a class. So all of this stuff that I've highlighted down here, the not instance variables, basically, we know what these are. These are methods. So the two categories of things that I expect to see in classes are instance variables and methods. The instance variables are the properties, the attributes that I expect all of these objects to have. The methods are the behaviors, the actions that objects can perform. Okay? Now, there are some kind of special methods that are worth paying some special attention to. So after the instance variables, we typically are going to see a very special method called a constructor. I'm going to spend a lot of time talking about constructors today. They are so very important. The role of a constructor is to create an instance of an object. So I use some computer science-y, jargony terms, right? Remember that a class is just a template. It's just a blueprint. It does not actually do anything. If I have a class, I don't have any objects. I have instructions telling me how I could create and use an object should I want to. But if I actually want an object, a physical thing to manipulate in my code, we have to use the constructor. The constructor creates actual instances of objects. So the way to kind of reconcile that is that here I'm telling you that a person must have a name and an email address and a phone number. The constructor says, all right, tell me exactly what name, email address, and phone number you want, and I'll make the person that has those things for you that you can then use to do whatever you want. So the role of a constructor is to make sure that all of the instance variables are properly set to an acceptable value by the time it's finished. That is its job. There are a few different ways that it can do that. In this particular example, we're using the parameters. So a constructor is a method. It is a method. It's a very special method, has a very special role, which again is to create an instance of an object. But it is in fact a method. We can see that by kind of taking a look at this over here. The signature looks a little off. It's missing some pieces. What's missing here? I heard somebody say, static's gone. That's a conversation we need to have today. There's something else that I would normally expect to see here that's also missing. Type? What kind of type? Return type. Good. Return type. Yeah. So the constructor, the way that you can look at something and tell that there's a few different ways, right? There's no return type. Constructors will not have return type. The name of the method is exactly the same as the class. That's how I can tell that it's the constructor as well, right? The word static being gone actually doesn't help us. That is a conversation we need to have today. And it is true that the word static is gone, right? But that in itself does not necessarily help us determine whether it's a constructor or not. The return type, though, consider that if we scroll down here, we can see the constructor in action. This line is an example of us using the constructor or calling the constructor. Remember, the constructor is a method. So to use a method, I have to call it, just like I would call any other method. The big difference between calling the constructor versus just calling any other regular method has to do with the fact that a constructor, again, I know I've said this a bajillion times, is responsible for creating a brand new instance. So before I use the constructor, nothing exists, right? I call the constructor and I now have a thing. It, poof, birthed this object into the world, right? That's what the constructor does. Creates that instance, and in this particular case, I'm sticking it in a variable. So I'm creating a variable. The type of that variable is called person. The name is P1. We've seen this word before, the new keyword. And then this is the name of the method that I'm calling. I'm saying create a person that has this name with this email address and this phone number. I wish to have a person with that information. And then once you've created that person, stick it in this variable. The new keyword is a special word that we use when we call the constructor. So when you see that word new, that's a big indication that you are calling the constructor. You are creating an instance of an object. The only other time we've seen the word new show up is when we're creating arrays. It's a similar idea, right? Similar concept. But we've seen this with scanner. Remember our good friend scanner way back? Scanner s equals new scanner. I was creating a new instance of the scanner class for us to use, right? We were using a scanner object. We didn't really tell you that. We weren't ready, but now we are. Anytime I have a class and I want to create a new instance of that class, I'm going to type the word new followed by the name of the class, that's the constructor, and then I'll supply whatever parameters are necessary. Okay? So the constructor's role in life is to make sure that these parameters are set to acceptable values. After the constructor, we'll have other methods, so other non-constructor methods. And again, these are actions that objects can perform. So in this very simple example, the only other method that we have here is a method called print. It doesn't do much, it just kind of shows us some information. I am still going to kind of walk through it with you, but just want to reiterate the idea that these are meant to be behaviors. So what else can people do? People can do lots of stuff. We can, run and jump and kick and throw things. If I wanted my person object to be able to do those things in this program, I could make a method called throw and then update the values accordingly when I throw something. Or I can make a method called jump, right? So our actions, our behaviors become methods. The attributes become instance variables. And then when we wish to use these methods, so we see I have a method here called print. If we come back to that idea of static versus non-static, we'll see that this thing is not marked static either, right? This is non-static. So the way that we use methods with objects is a little bit different. If I'm using objects as part of my code, I'm probably not going to mark things as static. So after today, after module 7, right, the amount of things that we mark static is going to go down dramatically. We'll talk about that a little bit more later. But let's talk about how to use these non-static methods with our objects. It's not enough to just say the name of the method. So in the past, I could just say, use this method, type the name of the method, followed by parentheses, and that was enough. That's not enough anymore. I have to call the method upon an instance of an object. So in order to use this print method, I can't just say print by itself. There has to be an instance associated with it. and we use the dot notation to make that connection. So I've created an instance of the person class called P1. If I wish to call the print method upon this P1 instance, I would say P1 dot print. That says use the print method upon the P1 object. If I want to use the print method upon a different person object, I can do that as well, right? Just switch out whatever's in front of the dot. And now the print method will operate on this instance and will print out this person's information. It's another word I've been using a lot in that sentence, right? This, I'm going to talk about that a little bit later on today as well. I've already covered a lot of ground, though. Does anybody have any questions about anything I've done so far? Yeah, I see a couple hands. Go ahead, yeah.
What's an object?
What's an object? I mean, an instance of an object. It's anything that can exist, right? Anything that can exist and be manipulated within the code. I think one thing that might help answer your question, perhaps in a little bit more detail, contrast what I'm doing with these objects versus the types that we've used up until this point. More often, things like int, double, boolean. Those can only have a single value, right? I can have an int that can be 7. I can have a boolean that's true or false, right? But I can't ever have, more than one value assigned to an integer variable. That's not possible. So if I want to build something that is more complex, I might need to take a few ints and a boolean and a double and a string and combine them together into a more complex type. And that's what building classes allows us to do. It allows us to take these things and create instance variables. They're not all packaged together under one type called person. And this idea that a class is a type is really powerful. Anywhere that I've used a type before, I can now use person. So that means that for parameters of methods, for all kinds of stuff. It's a great question. I know this is kind of a tangent, but it's good stuff. You'll notice too that ints, doubles, things like that, we have a name for those. Those are called primitive types. So primitive types meaning the smallest essence of data that can be recorded, right? An int is a number, period, the end, right? It's not a collection of numbers, it is one number. If I want to have a collection of things, I can do that. I can make arrays. Or if I want to have complex data structures, I can do that with classes. And we actually can see that with the names of the types. Int is lowercase. It starts with a lowercase letter. Same for double, same for boolean, right? These are called primitive types. I can only store one value. If I'm using a complex type, you'll notice that it's usually capitalized. So if I'm ever wondering if I'm dealing with one of those primitive types versus a more complex object-oriented type, check out the first letter. If it's capitalized, you're dealing with objects, which means that there are instance variables and methods associated with these things that you can access. Great questions. Any other questions I can answer? Yeah, in the blue.
Is P1 an instance?
Yes.
Okay.
And so is P2. I think it's useful though to make, again, it's a very abstract concept, right? Person is a template. That's a class. So it tells me what attributes a person has. All people have these attributes, right? Every single person that I create is going to have a name, an email address, and a phone number. Every single one. But they're going to be different. So my name, email address is going to be different than yours. It's going to be different than this person. So I am an instance. You are an instance, right? You are an instance. We all have our instance variables set to different values to represent us as specific instances. Does that make sense?
Yeah.
So I can call the constructor as many times as I want to churn out as many if I wanted to make, an instance for every single person in this room, I would have to call the constructor one time for every single person in this room, right? But I could do that. That's totally doable. Totally possible. Yeah, in the back.
So are instance variables like globally defined parameters and methods?
Instance variables are the more accurate way to describe it is to say that they're at the class level. So when you just define something as local, that to me says within a method. That's equivalent as saying within a method, right? These are class level, meaning that I can access this variable within this method. I can access this variable within this method, right? It's not just local within a single method, but it's throughout the entire class. Yes?
When we speak about being local in each parameter, in this time, is it data is local to a method? Is it local to all the methods in the same class, or it's only the method?
Only the method, yep. And that actually has to do with scope. You might want to go back and review the scope conversation we had in Module 5. Any variables that I create within a method can only be accessed within that method. That's what scope tells us. These class level variables are very useful. They have a wider scope. Again, but the scope argument still applies. Remember, scope is defined by these curly brackets. So these variables are created inside of these curly brackets, meaning that I can access them inside of any of these methods because they are also within inside of those curly brackets, right? Yeah. Make sense?
I have a question.
Yeah, what's up?
So is the object the public class person, or is it the constructor?
This is a class. Class and object is not the same thing. Yeah. I prefer the word instance. An instance is a class is a template, a blueprint, does not actually do anything. Just gives me instructions for how something would behave.
Okay, so what is the relation? Okay, so first thing, if you want to change the name or rename the class, you have to go back and rename the file. Right?
That is true. The file name has to be the same as the class name, yes.
So what is the relationship between the object person and the public static void main?
What is the main method for?
This is like how you execute
The main method is the entry point of the program. That's its job in life.
So can you like create an object here and create another file?
I can make a person object in any file I want to, now that I have this blueprint, yes. Yeah. And kind of similar, but not exactly the question you asked, I don't need a main method. I don't have to put a main method in a file. I can now no longer run this file, but it still exists as a template, and I can still use this template to make instances of person objects in a different file if I want to. That is still acceptable. Yep. Question?
Because I also still have a question. So why is it, like, I don't get it, why in these methods we do not need to write static or the return type?
We're going to get to the static question soon. The return type does still exist, just not for the constructor. And to think why the return type doesn't exist for the constructor, consider what the constructor is doing for us. If the constructor did have a return type, what would it be?
A string.
What am I making? Let's scroll down. I need to put the main method back. This is where I'm using the constructor. What is the type of the thing that is being created?
String.
Where do I see the type when I declare a variable? Person. The type is person. So if I wanted to define what the return type is here, it would be person. The return type is person. I am making an instance of the person class and giving it to you. That is what the constructor does. But this is redundant. Public person, person. It's redundant. So constructors don't include the return type.
So where did we identify person to become the return type? Is it in public class or?
That is how constructors work. Constructors create an instance of the class. Since I am in the person class, this constructor will create a person. If I am in a different class, then the constructor will create whatever that class is. Right? Great questions. Any other questions I can answer before we move on to some more examples? I know this is very abstract stuff, so I'm happy to go over anything again. Yeah?
But I just want to confirm, instance and objects are synonyms,
I have been very clear about using the word instance when I mean instance. An instance is a very specific copy of the class, right?
Okay.
Class is a template, an instance is a very specific thing that exists. It's a class is a cookie cutter, and the instances are the cookies, the actual cookies that you stamp out, right? Okay, let's take a look at some more examples. I want to talk some more about the constructor because it is such an important part of any class, such an important part of understanding how to create instances. So let's talk about the constructor, and let's start out by noticing that in this actual example I have two constructors, not just one, but two. That's okay. I'm not limited to just one. I'm not even limited to just two. I can have as many constructors as I would like. Think about what that means. A constructor is creating an instance of an object for us. If I have more than one constructor, that's just saying that there's more than one way to create this particular instance. More than one way to create an instance of this thing. So the first constructor up here we can see has no parameters, none. So this is what is called the default constructor. This is basically saying I just want a generic version of whatever this thing is. Just give me some generic default version of whatever this is. The role of the constructor is still the same, regardless of however many parameters that it has. So we have to make sure that the instance variables are properly set. That is the constructor's job. So if I have parameters, that's actually fairly straightforward. We'll do that one next. But if I don't have parameters, we have to decide on what these default values are. I didn't tell you what the model of the car is or what the year of the car is, so I just have to say what I want them to be directly. So I'll say this.model equals, it tells us to use default values of empty string, and this.year equals 2019. What is this constructor doing for us? This constructor says, if you want to make a car, and you don't care what the model is or what the year of the car is, you just want me to make you some default generic car, you can use this constructor, and I'll just crank out this basic car for you, right? That you're welcome to use. That's what this constructor is doing for us. If we scroll down here to the other constructor, it still has the same responsibility. It still needs to make sure that both instance variables are set to appropriate values. That is its job in life. So this time we've got values coming in as parameters. This is giving us the ability to create specific cars. I don't want to create just some random, some default generic car. I want to create a very specific car that I wish to use. So we are again going to set our instance variables, but this time we'll use the parameters that are coming in instead. Okay? Now again, I'm writing code inside of the class right now. This doesn't actually do anything. If I want to actually create a car, an instance of the car class, I have to call these constructors. I have to use these constructors. These are methods. I have to call them. I have to use them. So let's scroll down here. Let's try using both of these constructors. If I want to use the first one, I skipped a step. Always have to use the word new. When you're calling the constructor, we always have to use the word new. Anytime I'm creating a new instance of an object, right, I have to use the keyword new. It's actually a good sign for us. When you see that word new, I really want to train your brain to think instance. That's a new instance. We're then going to call the constructor. I'll call the default constructor first. This will make the default instance for me. with the blank model in the year of 2019. For the next car, for car number 2, I'll use the other constructor. I drive a Honda Fit. I know, we're everywhere. 2012. It's a nice car. So I'm creating 2 instances of the car class, but I'm using 2 different ways to do it. And that's okay. That's totally okay. There can be as many constructors as is necessary. A lot of times there will only be one. That is very common. But it's not uncommon to have more than one either. Not uncommon at all. What I would like to do is show you a couple things, though, regarding how these constructors work. I'd like to actually step through this code with you in the debugger. I think it's very useful to understand how this code is behaving. So I've actually got a breakpoint set on line 38 here, that first constructor call. And, oops, that's from last class. Sorry, let me start it over again. Okay, much better. So here we are. We're paused on line 38. Nothing's happened yet. This is the very first line of our program in the main method, right? No instances exist yet. If I look over here on the right-hand side, I don't see any variables. I see no references to cars, nothing. No cars have been created. No instances have been created yet. We're about to. The car constructor is a method. So I showed you how to use step into with the debugger. I can step into the constructor. So here we go. Here I am in the constructor now. I'm about to create an instance of the car class. If you look over here, there's actually a word in my variables window now. It says this. That's a very important word when talking about writing classes, making instances of objects. This is defined as whatever instance I am currently working on right now. So I could have 100 different instances, right? But this is whatever instance I'm currently working on right now. So this is if I'm in the constructor, this is about to be created. This is the instance that I am about to create. And so you can see right now the model is set to be null or empty. The year is set to be 0. But if I step through the constructor, you'll see that the instance variables then get set. There's the model. And there's the year. Question?
If you're working inside the constructor, will you always use this, or is there a different way?
So glad you asked that question. The question is about using this keyword. I was waiting for somebody to ask me about that. Let me finish stepping through this and then I'll come back to that question because it's a very important one. I do want to finish walking through this debugger first though. So I've created one instance of a car. And actually, if you look over here on my variables window now, you can see the instance. And if I expand the instance, you can see the model is listed as empty string and the year is listed as 2019. It's the default instance, right? Created with the default constructor. We're now about to run through the second constructor. So we're now going to create a Honda Fit. Again, here I am now in the second constructor. I'm using this one down here. And because I passed in these 2 parameters, we're about to see that when I create this instance, model this time is going to get set to be Honda Fit and year, whoops, I didn't do that right. That should be init year, but that's my mistake. Sorry about that. Okay, much better. Fixed it for me. So I now have 2 instances of the car class. One created with the default constructor, one created with the non-default constructor. But again, I want to reiterate this point, that if I'm going to call a method, it's not enough to just say print. I have to say print upon a particular instance. So let's think about what that means. When I call print, car1 is what I'm telling to be printed. So if I step into this method, here's the word this. Which instance is this referring to? There's only 2 to choose from. This refers to whatever instance I'm currently working on. Because I called this method upon car1, this is referring to car1. I can verify that by expanding, and I can see that these have the default values, just like I would expect car1 to have. It's the default car, right? But if I go ahead and I print out that value, and then I just call print again, notice this time car2 is on the left-hand side of the dot. So when I step through this code, what is this? It's not car1, it is now car2. And you can verify that by taking a look at the instance variables. I see it says Honda Fit in 2012 now. So think about what that means. This, it's a very important keyword, represents the instance that is being executed upon right now. So how do you figure that out? Look at the left-hand side of the dot. If I want to know what this is referring to inside of the print method, then I would just substitute in whatever instance it was being called upon. Now to get back to your question, you were asking about, do we need to have the word this in the constructor, or you notice I inserted it right here just now, and you can kind of tell by the way that Eclipse is behaving that it is somewhat optional to include the word this. It is not strictly required in a lot of situations. If I go back up to the constructor, let's look at this one for example. I can take this off and notice that the color is still blue, meaning that it is still referring to the instance variables, right? This works. There is no difference functionally between what I had before and what I have now. However, there's a couple things to note about that, a couple things to pay attention to about that. I'm a big fan of not just code that works, but code that's easy to understand. So if I can say something out loud, right? If I can write something down that makes it easier to understand, I will generally try to do that. So just because I don't have to include the word this, I oftentimes will do it, even if it is not required, because what if you're dealing with somebody who's colorblind, or what if your monitor is broken and you can't see the colors anymore? Now there's no question about what I'm referring to here, right? If this isn't blue for whatever reason, well, I could see the word this out in front and know definitely that is an instance variable. Has to be, right? If I take this off, okay, the blue is kind of helping me out, and I can still kind of figure it out if I need to, but it's a little bit more ambiguous. A little bit more ambiguous. I would prefer to remove any doubts. Furthermore, let's take that one step further. We've been talking about scope today. It's a good day to talk about scope, actually. Consider that I'm making some small tweaks here to this constructor. There's nothing wrong with this. This also will work, and this also is, I think, functionally equivalent to how we've had this example prior to now. But if I take the word this off now, we've got a little bit of a problem. So what's going on here? I have two variables in this example that happen to have the same name. This one is a parameter. This one is an instance variable. There's nothing wrong with that. I can have two variables that have the same name. The computer does not care. It will allow me to do that. But this is now ambiguous. Which one am I talking about? Am I talking about the parameter, or am I talking about the instance variable? They have the same name. It's not clear to me which one I'm talking about. And if it's not clear, the computer's going to grab the closest one. So what's the closest one? It's the parameter. It thinks both of these are talking about this variable, which is not what I want. That is not correct. That is not what I want. In this situation, you've got two options, right? I can include the word this to be very specific about which variable I'm referring to. Or, of course, the other way that we saw prior to this is to just make sure these are different names. And that way you don't run into that problem. I don't really care, right? I'm a big fan of writing this out, and you'll see me do that frequently in this class. But if you don't, I'm not going to like call you on it or mark off points or anything. I do think it's a good idea. That's why I do it. I would encourage you to consider doing it as well. But I do care the most about whether your stuff works. So if you're able to get it to work without writing out every little thing, then great. I'm happy for you. Okay? I know that was a long answer to what seems like a simple question, but we covered a lot of ground. Talking about this, you can see section 5. That was on my to-do list for today. I wanted to talk to you about this, so it was a good chance for us to explain that. Does anybody have any questions about the constructors as well as this keyword? That's what we've been talking about. Does anybody have any questions about those topics? Very, very important ones to understand. Okay, great. Then let's go ahead and move on to, we've got a couple more things that I want to chat with you about with the time that we have left today. Let's return to this idea of instance variables. I promised you that I would talk about this word private. So let's talk about what it means to mark things private. You can already have some sort of idea, public versus private. That's a concept we're used to. But what does that actually mean in the code? Let me show you. These are all currently marked as private. Okay? So here I've got just a very simple main method, and I've created a student to represent myself. So here's my name, my email address, and my student ID number that I've chosen for myself. And so you might, one thing that you might want to do is to just print out my name, right? So I might try to grab my name from the instance. So me is the student that I created, and I should be able to say me.name to grab the name instance variable out of that, right? Because all students have names. And you can see that if I try to do that, Eclipse doesn't like it. Eclipse says that the field, which again is another term for instance variable, is not visible. It's not visible. So this is an illustration of what exactly it means to mark something as private. If I mark something as private, that means that I cannot access that thing outside of the file where it's been declared. I can use this variable inside of this file all I want to. You can see the word name appears all over the place, right? I can use this inside the student file wherever I want to. As soon as I leave this file, because this is marked private, I am no longer allowed to access that thing. Private things can only be accessed within the file where they're created. So you might be asking yourself, okay, that makes sense, but like, how do you get the name out of this thing then, right? Like, what if you want to know this student's name or their ID number? How do I extract that information out? Your first inclination might be to come up here and mark this as public. We've used that word before. It seems like it would make sense. I can mark this as public, and actually if I make that change and I go back over, you'll see that other than the semicolon I forgot, Eclipse is happy now. I marked it as public, and that appears to have solved my problem. I can run this, and it spits my name out. Everybody's happy, right? Unfortunately, no. I'm not happy because there's a side effect of marking things as public that is not good, which is that I can come in here and do something like this, right? And change my name. And this is something that we generally do not want to do, at least not very often. It is true that people change their names, right? It is true that people change their email addresses or even their ID numbers. Those things, I think, can and do happen from time to time, but under very specific circumstances. We definitely don't want to allow just anybody to do this, right? This is something that should only be done by very specific people in very specific situations. Well, by marking this as public, we have given up all control over that instance variable. By marking that as public, we are saying that anybody can do whatever they want to with this. And that's probably not what we want. we probably want to actually have some control over who can see that value, who can change that value, how they can change that value. Those are all things we wish to control. So instead, we will never, 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 ever mark instance variables as public. Not in this class anyway, and I hope not in any of your other classes either. That would make me sad. I really never, 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 never mark these as public. There has to be a different way. So I can't mark them as public. So then how do I fix this problem? How do I access this stuff? We're going to use methods. There's two things that classes contain: instance variables and methods. So we're not getting there by manipulating the instance variables directly. Let's use some methods instead. If I want to read a value, if I just want to see what this is, I don't want to change the name, I just want to see what it is. Ask a student what their name is and have them report that information back. I'm going to create what's called a getter. So a getter is a type of method, a very common type of method, that follows a particular format. Public, and then the return type is going to be the same as whatever the type of the instance variable is that I'm working with. So string get name. And the body of the method is almost always going to look something like this. Return name or this dot name. Same thing, right? This is a getter. Very, very, very simple method. Allows us to read an instance variable. How does that change the code over here? I'm not going to try to access the instance variable directly. I'm going to use the getter. I'm going to use the getter. I will call the getter method upon the instance, and that will return the value. So if I run this code now, you can see that I can still use the getter to read the name, but if I come in here and I try to change this, it won't work. That's exactly what I wanted. I wanted to be able to see what that is without allowing anybody to blow it away, mess up my data, change something that they aren't allowed to change. That was the goal. But wait, let's take this a step farther. You can imagine that, okay, we do want to change things sometimes. So maybe we have a reason that we do want to allow people to change something for some reason. But a lot of times we still want to have some control. So think about an ID number. Let's say we did want to provide access to change the ID number. There's still some things we need to pay attention to. ID numbers typically, at least for here, are 6 digits, right? Or maybe another way to think about it is, I would never expect an ID number to be negative. That would be strange. If I saw a negative ID number, that would be surprising, unusual. But the computer doesn't necessarily know that. The computer just sees it as an integer. So any integer value is going to make the computer happy. Well, if I am using methods to control access to my instance variables, I can now solve that problem as well. So getters are used to retrieve the value of an instance variable, and setters are used when we wish to allow people to change the values of our instance variables. They also follow a very predefined, consistent format. So setter is always going to have a void return type. It's usually going to say something like set, and then I'll do ID, and it's going to take in a parameter. This is typically going to be, whatever the new value is set to become. I'll usually do something like this. But wait a second. I don't want to change it blindly, right? Now that I'm using a method to do this, I could do something like there we go. That's really nice, right? Now I have the ability to reject invalid ID numbers. If I just had this marked as public, just mark the ID number as public, That means that anybody can make any change they want to that value. They could give you a negative number, the computer would say, okay. Could give you a positive number that doesn't have enough digits. They could do all kinds of weird things, right? But by using a method, we now have the ability to control exactly what values we want, to have things make more sense. This is such a common thing that while yes, I did just write these out for you, type them out, and I actually would encourage you to do this too for the first few times that you do it. It's such a common thing that I typically do not write these myself. I let the computer do it for me. So you should type these out the first few times until you get used to the idea of what getters and setters are for. But eventually, as you become stronger programmers, you can rely on fancy tools. Eclipse, if you right-click and go to the source menu, you'll see an option on the source menu that says generate getters and setters. That sounds like a good tool. When you click on it, it pops up. Here's a list of all of the instance variables for the class that we're currently in. And so I can expand these out. You'll notice that I already created a setter for ID, and I already created a getter for name. So that's why it's not showing me. It can see that they already exist. But all right, let's look at email. I want to create a getter and a setter for the email address. I'll check those two boxes, click generate, and then poof, they just magically appear. Eclipse has created those for me. This is very common. This is a good programming technique. We are lazy people. We do not want to type stuff out if we don't have to. That being said, as students learning about getters and setters for the first time, I've seen the case where students can get kind of carried away and they'll just be like, all right, I'm making a class. I've got 3 instance variables, and now I'm going to make getters and setters for all of them. You can do that. It's not necessarily wrong, but the way to think about it is actually, I want to keep things as locked down as possible until I have demonstrated a need to open it up. Yes?
How did it know that you wanted it to be greater than 0?
I wrote this.
Oh, so what would it do for a setter like that?
So it's not smart enough to do this for me. The getters and setters that it will create are going to be of this style. So if I need additional work on top of that, I'm still welcome to come in here and change this code, right? These, the getters especially, like, I'm really struggling to think of the last time I wrote a getter that did not follow this format. So common. So incredibly common. Setters, while most of them, a lot of them will look just kind of like this directly, it's also a lot more common for there to be other restrictions, other kinds of things that we're looking out for that you as the programmer are going to have to recognize and go back in and fix yourself. Because the computer's not smart enough to know that ID numbers can't be negative. You have to tell it. Yeah, great question though. Yes?
I mean, to backtrack, do you mind explaining why I would need the getters and setters?
Yes, I'd be happy to. So I'm trying to illustrate that the idea that when I have a class, I have these instance variables, and sometimes I'm going to want that information in those instance variables to leave, right? To leave this class and go out into the world and do other stuff because information wants to travel around. That's part of the nature of computing and writing programs, right? By having things marked as private, it's very secure but limiting, right? So marking these instance variables as private provides us a great deal of security. I know that nobody's going to be able to come along and mess up my stuff. It's private. It's very restricted. But it also does not allow me to access it very easily. So I make the methods to provide the access that I want. The alternative to that would be to mark all of these public. And the reason that we don't mark things as public is because it does not give us any control. It's just a free-for-all. If I mark my instance variables as public, then anything goes. Anybody can do anything they want to them. By marking them as private and providing methods, it gives me more control. I can decide if I want you to, I can let you look but not touch. I can do the opposite. I could let you touch but not look. That's a little bit strange, but you could still do it. More often than not, you're going to allow people to look but not touch, or look and touch but only under certain situations. It's all about control. Yes?
So after you've created the like conditions in the setter, what happens if you try to set it to something that doesn't?
Yeah, that's a great question. So I did definitely kind of gloss over this because the idea of what to do, while a very important question, I'm not sure is on our agenda for today. But to give you a brief answer, the way that I wrote this code, if I passed in a negative value, it would just remain unchanged. I would just ignore the change. Is that an acceptable way of handling it? Some people might say, no, that's actually not good. If I told you to change it, you either need to change it or tell me why you can't. And that second step I skipped, right? I just didn't change it and didn't say anything. That's kind of rude. So, having an error message, you tried to change this and it was negative, that would be more acceptable. You would learn about that in 132 or other comp sci classes. Yeah, great question though. Fantastic question. Any questions about getters and setters that I can address before? I have one more topic with the time that I got. Any questions on this one before I shift and do one final topic? Yeah.
So if ID number is greater than 0, will that mean that like I don't understand what happens after.
So this method is used when I have a student and I wish to change their ID number. They already have an ID number. They exist. They have an ID number. I want to make it something else. So if I try to give you a negative number, this code will detect that and ignore it. Just say, no, sorry, can't do that. If you give me a positive number, then it'll let the change go through. Again, though, I think to do this properly, there would need to be more information provided, especially if you gave a negative number to be like, hey, I can't use this. You got to give me something better. Yeah, that's an important piece that is not currently here. Okay, the one final topic on our agenda for today. Let's talk about this word static. So I'm kind of dancing around the issue a little bit, yeah, let's talk about it. So I want to start off the conversation with static. I am going to show you some code examples, and you've actually been using static things for quite some time, right? In fact, everything that we've been doing up until today has been static. You've been writing static methods. And I want to make something very clear, especially for next week, for exam 2, right? Exam 2, all of the methods will be static. All of them, right? This material is not going to be on exam 2. So this concept that I'm talking to you about, static versus non-static, for exam 2, you can just assume everything is static still. We'll deal with the non-static stuff on exam 3. It is a very important topic to understand, though. So let's talk about it. We've got instance variables, and one thing that I haven't shown you is that we can also have static variables as well as static methods. So we've seen static methods before. We've been writing static methods, lots of static methods. We've been using static methods. Math.random, that's a static method. Math.round, that's a static method. So we've been using static methods. The difference between static methods and static instance variables versus non-static instance variables and non-static methods. This is an example of a non-static method. Static things belong to the class. They do not require an instance to function. Non-static things require an instance of the class in order to operate. So if I want to call a non-static method, right, I have to first create an instance of this class by calling the constructor, Once I have that instance, I can then call the non-static method upon that instance. If I am using a static method, I don't have to call the constructor. I do not have to create an instance. I can just call the method directly. And we've been doing that. So to show you an example between, static and non-static things, this is a static method being called. Print person counter is a static method, but p1.toString, this is a non-static method. So the static method is being called upon the person class. That is what we say, that is what we mean when we say that static things belong to the class. Static variables and static methods all belong to the class and are called upon the class. Non-static things require an instance. So this one is called upon an instance that was created by the constructor. Other implications of this, so other ways of thinking about this. If I'm looking at a method, right? If I'm looking at a method that is accessing non-static instance variables, then that method also has to be non-static. If I'm looking at a method that is accessing static instance variables, then that also has to be a static method. Or you can think about it in the opposite way. If I have a static method, I cannot access non-static instance variables. It is not possible. Or, I know I'm giving you like a whole bunch of different ways to think about this, but I'm really just trying to illustrate this concept. To think about the difference between static versus non-static variables, consider every time I create an instance of person, I know that that instance is going to have a name and an email address and a phone number. So if I call the construction once for me, I have a name, email address, and phone number. If I call the constructor for you, you have a name, email address, phone number. If I call the constructor for you, name, email address, phone number. For static variables, there is one copy of this that we all share. So this person counter, if I look at it and it says 10, and you look at it, it's also going to say 10. And if I add 1 to it to make it 11, and then you look at it again, you will also be able to see that it is 11. There is one copy of it that is shared across all instances of the class. That is the difference between static and non-static things. Now, let's talk about the practical implications of this. So let's start off by talking about what this means on assignments and exams and things like that. For assignments 7, 8, and 9, the stuff that we're doing for the last third of the semester, I am not going to ask you to write static things anymore. Like, it's not going to happen. With one very important exception. This guy right here. Main is not going anywhere, and main is always static. Always. Always. So if you find yourself writing a static method for assignment 7, 8, or 9, that would prompt some questions from me, for sure. For assignments 5 and 6, they have to be static. That is required. For the exam next week, static. Static, 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 static. For the exam next week, static. But then after that, we're pretty much dropping it. We're sticking with non-static stuff. We're going to be using objects. We're going to be creating instances. We're going to be calling the constructor all the time. Another very, very, very common thing that happens to people is that, so it's a tricky concept. I'm not going to sit up here and pretend that, this idea of static versus non-static is a very easy, natural thing to understand. It's not. It's a tricky concept. So sometimes I'll see students, they'll try to call a non-static method. So this is a non-static method, but trying to call it in a static way. And this is a problem. Obviously, it's not going to work. But the bigger issue that I have is what Eclipse tells you to do or suggests for you to do. If you try to do this, it says, cannot make a static reference to the non-static method. And the suggestion is to make the method static. Stick that word static in there. That is not what you want. In fact, it ends up having kind of this domino effect. Now that this method is static, it's trying to access these instance variables, but it can't do that. Static methods cannot access non-static instance variables. So Eclipse is going to make another suggestion and be like, well, okay, let's just make the instance variable static then. That is not a good idea. That is not a good idea. Resist the urge. If Eclipse is suggesting maybe you should make something static, please resist it. I don't want to say it's going to be wrong every time. There are definitely situations in which marking things as static is the appropriate thing to do. But as we move along, those are going to become pretty rare events, things that you are not going to be expected to do as often. More often than not, keeping things non-static is going to be the more proper thing to do. Yes, that's my big advice to you. Starting with Module 7, kind of pretend like you don't know that static exists anymore. That'll get you a long way. Every once in a while, you may find a justified need for it, but that should be the exception, not the rule. That's the biggest advice that I can give to you regarding static versus non-static. On the exam, so exam 3, remember, not exam 2. I will not ask you about static versus non-static on exam 2, but on exam 3, I would expect you to be generally aware of what the difference is. Am I going to ask you to, write a bunch of static things on exam 3? No, definitely not. That's not what we've been learning about. That's not what we're going to be doing. For 7, 8, and 9, it's basically no more static stuff, except for main, from here on out. So make a note to yourself. Keep that in mind as we go along. Creating instances is important. Using the constructor is important. I want to leave you with one final example, but before I do that, does anybody have any questions? Okay. So I'm going to leave you with an example that's going to be very helpful to you coming up on the assignment 7. So I'm going to give you a good little push for assignment 7. Earlier I looked at a class that represented a car, right? That represented a car. And if I wanted to, you could conceive of, okay, I could make a garage. I'm thinking like a big parking garage, right? That can hold lots of cars. And so whenever I'm making a new class, I'm going to remember that there are 2 categories of things that go in classes. There's instance variables. There are methods. Specifically, there's constructor and then other methods. So I know I'm probably going to need at least one constructor, so I like having a spot for that, and then whatever other methods that I want. I'm not going to have time to fill out this whole class today. I just want to illustrate an important example to you about instance variables and classes and what we've been doing. I think one good instance variable could be an address, right? So where is this garage actually located? But let's talk about what this garage is going to contain. It's going to probably contain some cars, right? I have a class that represents cars. I can make instances of cars. When I make a class, I'm actually defining a new type. I'm saying that the types that are available to me are not good enough to express what I need to express in my code. I'm going to make a new type that represents cars. What properties do cars have for my program? What behaviors do they have? Well, those are the instance variables and the methods. But now that I have that definition of what a car is, I can use that anywhere that I would use a type. And we've already seen this. I've made variables that have type of person and student, right? We can have parameters. So parameters have types. But another thing that has types that we've used that could help us here, if I think about a garage, it doesn't just have one car in it, right? It has lots of cars, or it has spaces for lots of cars. What do I use for collections of things? Everybody's favorite. Arrays? Okay? So I have an array of cars. An array of cars. Well, car is a class that I wrote. Yeah, great. Awesome. Cool. That's a good thing. That's a good thing. So when you think about what the role of the constructor is, remember, the constructor's job in life is to make sure that both of these have legitimate values. And that includes this car array. It is still the constructor's job to make sure that car array is set up properly. So what does that look like? Well, for the address, we could probably, do something like this. But for the car array, what information do I need to make an array? I go to the garage. Big parking garage. Probably need to know how many spots it has, right? How big it is. So you may have been perhaps expecting me to pass in an array here. You could do that. You could pass in an array here for the parameter. I'm going to play it a little bit differently though. I'm going to take in a value for the size and think about what I'm doing now. I'm going to set my first instance variable. Again, the role of the constructor, I've said this I don't know how many times today, is to make sure that all instance variables are set to an appropriate value. Right now, I've done that for this one, but I still have to do this one. For an array, for a collection, that usually means creating it. Equals, how do I make an array? New car size. What is this line of code doing? This line of code is creating an empty array of cars. So once I get down here to write some methods, which it doesn't look like I'm going to have time to do today, unfortunately, I'm going to have one that's called park. And it's going to take in a car, and it's going to stick that car into this array in the first spot that it can find that's empty, right? That doesn't already have a car in it. And that's okay. You're going to need to do something like this on homework assignment number 7, something similar to this. This idea that we can take classes, we can take types and use them to create other types and other classes is an important one. Very, very, very important one, but also extremely abstract. In fact, everything that we've talked about today, so high level, so abstract. I understand if your brain feels melted a little bit, it's going to take some practice. But if you have any questions, please let me know. Come and see me in my office. I'd be happy to chat to you about any of these examples, go over any of this stuff for you. Otherwise, that's all I got for you for today. Have a good rest of your week, okay? And I'll see you in the labs on Wednesday and Thursday.